Greetings, my little triglets. Welcome back to online videos. Today we are going to be doing section 5.2, and we're going to talk about the trig identities. Some of them you already know because you've learned SOHCAHTOA. That's what you do when you hit your toe in the door. You SOHCAHTOA in the cold water. SOHCAHTOA. SOHCAHTOA stands for sine, cosine, and tangent, and it deals with the triangle. Sine is opposite over hypotenuse for the ratio. This is adjacent over hypotenuse and opposite over adjacent. So on a triangle, here's our angle. We'll call it angle A. Here we have little a. Here's angle, we'll call that angle C, and here's angle B. And then here is little c, and here's little b. So if I wanted to know the sine of angle A, I would take the opposite A over the hypotenuse, which is always across from the 90 degrees, so A over C. Cosine of that angle is adjacent B over hypotenuse, so adjacent is the angle touching angle A. And then tangent of A is opposite, which would be A, over adjacent, which is B. So it's all a way to figure out angles and sides when you have limited information. Now what you probably didn't know is that each of these has an evil twin. I'm going to choose the color red because that's the most evil color I can think of. So sine's evil twin is cosecant. Cosine's evil twin is secant, and tangent's evil twin is cotangent. Now the big way to remember, now tangent and cotangent are easy to remember, but the other ones, the S and the C and the S, they don't match. So the S does not go with the S. Now they're evil because we don't have buttons on our calculator, so it makes it harder to figure them out. But they're simple in the fact that all they are is the reciprocals of their twins. So cosecant is really 1 over the sine, or hypotenuse over opposite. Secant is 1 over cosine, or adjacent, or hypotenuse over adjacent. And cotangent is 1 over tangent, or adjacent over opposite. So evil twins, but they're pretty simple to find. You just have to flip them over. All right, so let's do a problem that involves all 6 of them. All right, so I have this triangle, and I'll call this A, B, and C. And we know that this side is 5, this side is 12. I want to find the 6 trig functions. Now remember the first 3 letters of the word functions. Okay? It is fun. You just have to believe it. All right, so what we need to find is sine, cosine, tangent, and then cosecant is abbreviated CSC, then secant, and cotangent. Now to get these, I need to know what the hypotenuse is. And we have a right triangle, so Mr. Pythagoras gave us a very easy way to do this. I'll call that c squared, so I have 25 plus 144, 169, so 13 equals c. So I can put that in right there. All right, so sine, let's say we're taking of angle A, sine of A. All of these are of angle A, because it changes. If it's angle B, then everything gets switched around. So sine of angle A is opposite over hypotenuse, so 5/13. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's 5 over 12. If you notice, Tangent could also be thought of as sine over cosine because I have 5/13 over 12/13. I flip this one over. That was 13/12. 13 cancels. You're left with 5/12 right here. And that's what our tangent was. So another way to think of tangent is sine over cosine. That's another identity. Besides those 6, it has another one. So in knowing that, what about cotangent? If cotangent is the reciprocal of tangent, it should just be cosine over sine. All right, so we have all the reciprocal ones, and then we have these two that add into that as well. All right, so we figured out those 3. Let's figure out these 3. Well, 5/13 flipped over is 13/5. 13/12, and 12/5. Okay, so that's pretty easy once you know them. Now you have special angles that we're going to eventually memorize, and we're going to draw a circle in class that has all this in there. In fact, we might have already done it, depending on when you watch this video. So our special angles are the 30s, 60s, and the 45s on the circle. Now you remember from Algebra 2, hopefully, if this is a 30, the ratio is 1 to 2 to root 3. And then if you have a 45, both of them are 45, the ratio is 1 to 1 to root 2. So it's almost easier to make a chart of all of these. So I'm going to do that real quick. You can also find this in your book. I have 30, 45, and 60. Let's go with sine, cosine, and tangent. All right, so the sine of 30, here's 30, opposite over hypotenuse, so 1/2. The cosine of 30 is adjacent over hypotenuse, so root 3 over 2. Let's look at the 45. Opposite, here's our 45. Opposite over hypotenuse, 1 over root 2, but remember we got to get the radical out of there, so it's root 2 over 2. Now the cosine, it's going to be backwards for the sine and cosine, they're going to be opposite. So if I do the cosine of 30, I have adjacent over hypotenuse, root 3 over 2. See how that used to be on the 60 there? So they're kind of opposites of each other. Then the cosine of 60, here's our 60, is adjacent over hypotenuse, so that's 1/2. See how they switch places? We got this one here, we got this one over here. Now 45 doesn't change. Whichever 45 I pick, it doesn't change. Doesn't matter which order I go because it's always going to be 1 over root 2, which we already said was root 2 over 2. Now tangent, I'm just going to look at sine over cosine. So I have 1/2 over root 3 over 2. The 2's are going to cancel. I have 1 over root 3, but getting the radical out of the bottom, I get root 3 over 3. Now what about this one? Sine over cosine. Everything cancels and it's just 1. And then for 60, it's root 3 over 2 over 1/2. 2's again cancel. I'm left with root 3. So those are the basic ones. And I will show you on the circle how those work. Now let's do another problem where I'm going to give you sine and cosine. And so you're given that sine of some angle is 2/5. Now that isn't one of the ones we just did. Cosine of some angle is root 21 over 5. I want to find the other 4. So tangent is pretty easy. You just do sine over cosine, so 2/5 over root 21/5. 5's cancel. 2 over root 21, which is 2 root 21 over 21. All right, next are the evil twins. Cosecant is just flipping over the sign, so 5/2. Secant, we flip over and get 5 over root 21. simplifying 5 root 21 over 21. And then, oops, cotangent is flipping over tangent. Now, if you look at this one, it's not as pretty as this one because this one, you're going to have a radical in the bottom. If I flip this one over, my radical is in the top and I'm done. So I'm going to save myself a little bit of time. Okay, so that's how it goes. You just find tangent by sine over cosine, then flip them over. Now, some more identities are called the Pythagorean identities, and they call it that because it works a lot like the Pythagorean theorem. Instead of a squared plus b squared equals c squared, we have sine squared plus cosine squared equals 1. So it works very much the same as the Pythagorean theorem. Now that's the first version. There are two other versions. And if I divide all of these by sine squared, I will get sine over sine is 1, cosine over sine is cotangent squared, and then the reciprocal of sine is cosecant squared. So that's version number 2. Now what if I divided all of them by cosine squared? So sine squared over cosine squared is tangent squared. Cosine over cosine is 1. And 1 over cosine, the reciprocal, is secant squared. Okay, so the only one you really have to memorize is this one because you can do this division thing to get the other two versions. So you are going to have to memorize those. All right, couple more problems and we will be done for the day. All right, let's say you are given that the sine is 3/5, sine of some angle, and we know that theta is an acute angle. I want to find cosine. All right, there are two ways to do it. One is to actually draw. If we call this theta, sine is opposite, over hypotenuse. So opposite is 3, hypotenuse is 5. And if you do Pythagorean theorem, this is a 3, 4, 5 triangle, so I know that this side is 4. So now cosine is adjacent over hypotenuse, so I know cosine is 4/5. Okay, so that's one way to do it. The other is to use our sine squared plus cosine squared equals 1. So I put 3/5 squared plus cosine squared equals 1. This is 9/25. I'm going to subtract that from both sides. Now 1 I need to make 25/25. Okay, so that's not there anymore. To be able to subtract 9. So cosine squared equals 25 minus 9 is 16. Then square root both sides. So I get 4/5. Okay, so you get 4/5 either way. I'm thinking, drawing it's pretty fast. You might have to do Pythagorean identity or Pythagorean theorem to find the third side, but it still works. All right, the last thing I want to talk about is your DRG button on your calculator. This stands for degrees and radians and gradians, which we don't use, but you have to push that button to change from degrees to radians. So very simply, sine of 46 degrees, you just make sure your calculator is in degrees. You hit the sine button, you hit 46, you hit equal, and I get 0.7193. So why don't you check that? So if you have a little degree symbol, that means you have to be in degrees. If you don't have a degree, let's say it was just sine of 46, that means it's in radians. Now I didn't figure that one out, but just notice the difference. If there's no degree circle, then it's in radians. Let's try the cosine of pi over 12. Okay, that has to be in radians. There's no degree symbol. So again, in radians, I get 0.9659. Okay, so you should try that and see. Now let's talk about the evil twin here. What if I want secant of pi over 12? I don't have that button, but I know that secant is equal to 1 over the cosine of pi over 12. So since I already know this, I could just say 1 over 0.9659, and you should get 1.035. So because you don't have this button, you're going to have to do the reciprocal of the button you do have. All right, that is it so far for this section. We'll do a few more notes in class, but that's it. All right, so you take care, and don't forget to add Trig love into your life. Ta-ta.